Okay, let's dive right in. This sounds kind of like a riddle, doesn't it? How can the way a flock of birds flies have anything to do with stocking shelves and making a business more efficient? Well, it turns out nature has been solving these crazy complex problems for millions of years, and we're just now starting to take notes.
So that's the big question we're tackling. We're going to connect the dots between biology and the bottom line, and I'm going to show you how the way a flock searches for food can solve one of the biggest, most expensive headaches in the entire retail industry.
But first, to really get why the solution is so clever, you have to understand the problem. And for any retail business, from a tiny corner shop to a giant superstore, it's a constant, high-stakes balancing act.
People in the industry actually call it the Goldilocks problem. You can't have too much stock, you can't have too little. Everything has to be just right. And believe me, getting it wrong, even by a tiny bit, can be a huge, costly mess.
And it's a total catch-22. If you order too much, you're bleeding money. Your cash is just tied up in boxes that are sitting there gathering dust, you're paying for storage, or even worse, watching perfectly good products expire. But if you order too little, now you've got empty shelves. That means lost sales right now, and maybe even worse, unhappy customers who decide to shop somewhere else next time. It's a massive dilemma. So if the old school business models are struggling with this, where do you even start to look for a better answer? Well, the researchers behind this study, they had a pretty brilliant idea. They looked up.
That's right. The key to cracking a 21st century supply chain problem wasn't buried in some dusty textbook or a complicated spreadsheet. Nope, it was in the collective, swirling intelligence of a flock of birds. It's an amazing field of science called biomimicry.
And this brings us to the main event, a concept called particle swarm optimization, or PSO for short. It's this really powerful algorithm that basically translates the simple rules birds use to find food into a computer program that can solve problems. Now, here's what you need to remember. The success of the whole thing really boils down to two key ideas: how many birds you have searching and how well they all communicate with each other, okay? The size of the flock and how well they share info. Hang on to that. It's going to be super important later.
So how does this actually play out? It's beautiful, really. Just 4 simple steps. First, you have your virtual birds, they're called particles, scatter across a landscape, all looking for food. In our case, food is the cheapest possible inventory cost. Okay, step 2. Every single bird remembers the best spot it has found on its own. But here's the magic. This is step 3. The entire flock is instantly told about the single best spot found by any bird in the whole group. And that leads to the final step. Every single bird adjusts its course. It's pulled by 2 things: its own personal best discovery and the flock's absolute best discovery. And by repeating this simple process, the whole group just zeroes in on the best solution incredibly fast.
All right, so the theory is cool, right? But does this bird brain logic actually work for stocking shelves in a store? Well, that's exactly what a research paper by Kimchann Chon decided to find out in this really cool virtual experiment.
So here's what they did. They built a computer simulation of a retail store. It had 4 different products, and they ran it for a 12-day sales period. The whole goal was simple: let the PSO algorithm, our flock of virtual birds, figure out the absolute perfect amount of each product to order to get the lowest possible cost.
But, and this is the key, they didn't just run the algorithm one time. They set up a kind of bake-off. They actually tested 4 different versions, tweaking the rules for the flock each time, to see which set of instructions would give them the best results. And this is where it gets really interesting.
Which brings us to the results. And honestly, this is where you see just how insanely powerful this approach can be when you get the details right. The difference between a good strategy and a great one wasn't just a little bit, it was staggering. And this right here just says it all. Both of these graphs were created by the exact same algorithm. But just look at the difference in the final cost. The line on the right ends up so much lower than the one on the left. So what gives? It's all about the tuning. After running through tons and tons of different possibilities, the algorithm finally found it. The absolute best-case scenario, the one perfect inventory level that resulted in the lowest possible cost, and that number was just over 7.5 million. But a number like that doesn't mean much without context, and the context here is absolutely jaw-dropping. That best-case scenario? It was a full 86% cheaper than the worst-performing version they tested. 86%! Can you imagine telling a company's CFO you found a way to slash their costs by that much just by changing a couple of settings? So, what was the secret sauce? What was the winning recipe?
Well, it came down to those two factors I told you to remember. The big winner, Test 4, used a large swarm size. That just means they had more birds searching for food, and a high global learning coefficient, which is a fancy way of saying each bird paid a lot more attention to the best spot the entire flock had found. It's that simple. More searchers and better communication. That's what made all the difference.
So what's the big lesson here? What does this virtual experiment really tell us about solving problems in the real world?
You know, the lead researcher Kimchann Chon really just put it perfectly. The size of the swarm, how many different options you're looking at, and that global learning coefficient, how well the group actually shares its best ideas. Those two things can make a huge, significant difference. More searchers and better communication get you better results. Simple as that.
And that really is the biggest takeaway. It's not enough to just have a powerful tool like an algorithm. The real breakthrough comes from knowing how to tune it, how to dial it in just right. Think of it this way. Having a race car is one thing, but knowing how to drive it to win the race, that's the whole game.
And all of this leaves you with this really fascinating final thought. If a flock of birds can help us optimize the supply chain, what could we learn from the web of connections on a forest floor? Or the incredible structures inside a termite mound? Or the collective smarts of a beehive? It kind of feels like the blueprints for solving some of our biggest problems are already all around us, just waiting for us to notice.